That's too much bandwidth.
Okay, but we are online.
Yay.
We're streaming. Hello, everybody.
Good. Hello, everyone. Welcome to lucky number 20 in session.
20, yes.
20.
And I realized we've been slacking a little bit this year, actually. This is just our third in session this year, I believe.
I know.
Anyway.
It feels like we've had a really, really long summer.
We're trying hard.
Yeah. So I'm experiencing some technical difficulties and my video is really slow, but we're very, very happy to be here. We have with us from the derivative team, Jarrett Smith and Greg Hermanovic. And we are extremely pleased to have with us the very prolific artist, Matthew Biederman, who since the mid-90s has been performing and exhibiting works that investigate themes along the sort of perception, data systems, and media saturation from many points of view, and very often with TouchDesigner. So welcome, Matthew. Thank you for being with us today.
Thank you. Happy to be here.
Yeah, very excited to have you. This has been a long time coming.
It's been a long time coming, and we've spent.
Yeah, we've had you in our sites for quite a while, actually.
Yeah.
You don't know that.
Yeah. Well, we were just talking earlier about how long we've known each other, and it was since the very, very first workshop, TouchDesigner workshop at MUTEC in the basement of the Satosphere, back in 2007 or 8, something like that.
I believe so. Yeah.
That's a long time. So, so we just wanted to show Matthew's website here because it's really interesting, and as you can see, there's a huge amount of work that we can't possibly cover. But I was thinking that the way that you talk about your practice is really interesting. The fact that you see the artist sort of as a provocateur and someone who sort of shines light and understanding on ways of perceiving the world. Also, you tend to avoid the sort of the typical categorizations in the art genres like, painting and sculpture and live visuals or whatever, and rather you filter your work. I don't know if you guys can see the sub-menu on the left here, which is very interesting. So it's filtered by perception and color and tactical and things like that. So maybe, Matthew, if you could talk a little bit about how this comes about. I mean, is this something that you kind of knew from the beginning, or is this something that sort of progressively found a way of defining what you do?
Yeah, I think it kind of happened naturally. I tend to work very intuitively in some ways, and I get interested in a particular subject or way of thinking, and then try to follow through with a particular set of ideas, either with one project or many projects. And there's starting to be an overlap, and I came up with a little menu on the side because people were telling me, I go to your website, I'm totally confused. Like none of the work seems to fit together. So I sort of had to come up with some ideas of where the overlaps were. And even some of the subjects are kind of overlapping. And I sometimes have a hard time figuring out where they actually belong. But maybe it's my own problem that I don't stay in one zone long enough to just have a very complete body of work, as they say. But it's but I tend to move and cross over, and I think that also some interesting crossovers can happen when you work like that. I don't know that I want to stay hyper focused on any one particular thing.
Personally, I don't think it's a problem.
It's kind of apparent here, even with the spectrum, under the spectrum attack, there's a color.
Well, exactly. I mean, right there's light, sound, because there's radio and color, and it's kind of, and then there's how it's all part of the electromagnetic spectrum. It's just kind of how we decide to decode it. I always thought our eyes see a particular set of frequencies, and radios just say they kind of transform another frequency into something that we can hear, or television broadcast for those of you who remember television broadcasts, it's also a way of kind of detuning and kind of bringing things into a human perceptible kind of zone, I guess.
Mm.
So I mean, can you give us a little background? You were born in Chicago and now you're in Montreal, and sort of what happened in between. What did you make a lot of your own machines, and you build a lot of the hardware in your installations, and you sort of customize software, and obviously you work with TouchDesigner, but so what's the background of it?
Yeah, I grew up in Chicago. I went to art school, or a regular public school that just in their art department. And again, back then it was called Intermedia Arts, and it was really just, we studied everything kind of time-based, and so there was video, there was film, we had to do performance, there was music. And it's in fact, that's when I was introduced into any kind of working with software, was actually through the music department, although I don't consider myself a musician. And we were introduced to Max, and I would always try to use it to do things that were not, because I have two left ears when it comes to making any music. I love it. But, I was always trying to do things that were a little bit different with the software. But after that, I wanted to go to California to be with all the other media artists. At least that's where I thought they all were, in San Francisco. And I was part of a team that ran an Artist Friends Center, like as best you could say that, for the United States. It was called Artist Television Access, which is still there, by the way. And there were, every weekend we had screenings, but we also had computer workshop, video editing suites, and we were always running some other class or something. So it's always been really important to me to create that kind of access to newer technologies, whether that was video editing back then, or just having like a computer lab where community members could come in and get online. I mean, then in the early 90s, it wasn't so easy. So we had really cheap access, or we had classes, video production for women. I also did like after school programs for kids and got them into video production. So that's always also been part of my practice. And it's kind of why I started in media art anyway, because I always felt it was a much more accessible form of art than kind of rarefied paintings and marble sculptures for rich people in their homes. But so I always thought television, that was the way to to speak to others or whatever. Yeah, like, because we were all really familiar with it. I could show my parents work, and they were it was much easier for them to kind of have an access point because it was on a television screen, and
Exactly.
that's rather
Right.
than white box kind of stuff.
So what year was that? Sounds like it's like 80s kind of thing.
Yeah, I mean that was like 1992, I guess, was San Francisco. I was there for like a decade or so. Yeah, I left in about 2002. I left San Francisco and then came to Montreal, and I'd been going back and forth doing different shows and exhibitions in Montreal. Somewhere in the middle there in San Francisco, my own kind of art practice started taking more and more of my time. I also worked at SF MoMA for a while, caretaking for their collection and kind of putting stuff together. So, that all those experiences together just kind of had me, and at the same time, I should say, I started doing, it was much more available to do kind of real-time visuals at clubs and raves and things like that. So I was really involved in that sort of community in San Francisco. So doing a lot of underground work, which kind of led me to do performances. My first performances in Canada were to do the visuals at the Jazz Festival, which was at the Spectrum back in the day. Like, so they're kind of late night gigs. And then I started doing a couple like micro Mutech shows and things like that. And I thought, I need to move to Canada, to Montreal.
It's all there.
And Montreal has always been such a great place for this kind of work, right? I mean, basically the Montreal community were some of the early adopters of TouchDesigner.
Mhm.
Right? So,
That too. Yes, and
so then,
many,
go ahead, Greg.
nothing.
So then the science part, I mean, say we dive into some of the works in the perception part of your anthology here. There's two things in that piece. So one is sort of reflecting on the simultaneous behavior of light as a wave and a particle. And then it's also looking at what's the what is the man-made thing that shows gosh.
The material that is
Yeah,
that
sort of
diffracts, refracts, or
biomimicry,
what it,
exactly. The
Yeah,
bio,
it's
bioluminescence. No, not bioluminescence. It's the
dichroics. I even brought it. I haven't
thank you.
in my
Oh, there it
test
is.
because it's
Wow.
yeah, it's a dichroic material, so only certain wavelengths are reflected at certain angles. So this one is blue or red, depending on whatever.
Photonic crystal.
Oh yeah, well that's
That's
that one's mimicking a photonic crystal, but
okay.
to back it up a little bit, I guess, I was always interested in color and the way we perceive color. And so at some point you just start getting into the kind of science of light. So that's kind of what led me there. And so I was invited to do a residency at a nanosystems laboratory. It's in northern Portugal. They have a great art residency program there. I highly recommend everybody tries to look for it. It's called Scale Travels. And in fact, there's been a lot of touch designers that have been through there over the years.
Wow.
In fact, it's in Braga in the north of Portugal. But they have, and there I was embedded with some scientists who work in photonics. So I was kind of just hanging around with them and kind of learning about different parts of their research. And one was really looking at these photonic crystals. And it's, in the same way that like butterfly wings work, or like a green beetle or whatever, like it's not a dye that then only reflects that color of light, but there's an actual structure that grows on the wings of a butterfly or is on the beetle's back. That's like a crystal that refracts the light. So it's not like a dye the way that sort of works. Whereas like the grass is green because it's absorbing all the other colors and only reflecting back the green is why the grass looks green. So this works in a different way. It's that's why they look kind of iridescent, where these things look iridescent. And so they're building at this, one of their projects is to 3D print photonic crystals that might, say, for instance, work better for solar panels, so that the light's reflected back and they become more efficient, or I don't know, all the other applications.
Yeah. So they're trying to make light coming at weird angles go straight into the detectors or the converters to electricity, stuff like that.
Exactly. Yeah, and it's
So
they're okay. Go.
So you say this is like mimic this is mimicking the the materials or
Well, one
is it
of
coated
the
with it?
like one of the crystals that they make is called a log pile. So that's really the structure of these LED tubes. And then like with this thing, it's usually pretty boring with this material, right? Like it's blue or red or, purple or whatever. But when it's on a flat plane, it's not so interesting. And I was playing around with it, wrapping it in tubes. And then I had this idea to wrap it around the LED tube. So weirdly, you're kind of experiencing what is happening with these photonic crystals and kind of seeing it. It's sort of a weird meta twist, I guess, is that it's only letting certain wavelengths in certain directions, and the animation is just is like a wave pattern kind of.
It's very kind of regular ramp, like circular ramps, animated, but is actually going through this material that is on the surface of the tubes.
Exactly. There's two. I think the actual color of the LEDs it's like green and purple before it
Oh,
comes out like blue and red on this thing. It's a
wow.
really weird kind of effect. You can sort of see it around the edges.
Hmm.
But yeah, it was kind of a fun thing to experiment with. It's like two
Yeah.
concentric circles that then kind of drift apart and come back together, and they kind of
Hmm.
change their wavelength and frequency. But that's also the way that light actually behaves in space as well. If you look at it as waves and
Hmm.
not particles, because there is this, of course, duality that
Yeah.
nobody quite understands still, which is
We
it's
like
fascinating.
talking about it intermittently.
Yeah, yeah,
Yeah. Every few months, there's an article about, light being photographed, behaving as a wave and a particle.
yeah, slowing it
So,
down.
yeah,
It's endlessly fascinating
Hmm.
endlessly.
material.
Hmm.
So it's fun to
So,
work with that. And I always kind of thought of screen-based work, the other screen-based work, and even projected. It's interesting to consider the regular arrangement of a screen or projector, the grid, as like a whole bunch of tiny light bulbs rather than a window into which you see. So that's always been a kind of one way of kind of freeing my brain to think about different things rather than like what's the image that I want to produce. It's like how do you rearrange a particular experience of what is coming off of a screen. So it
yeah.
was a really fun jump to work with the LEDs.
Hmm.
It's
Awesome.
more of what's hanging behind me, but it's not running right now. So
No.
we'll see what happens.
Yeah, my notes, which I finally found, is I had this piece marked with optical illusion, perception, science, and trickery. I think trickery factors really highly in a lot of your work. I mean, going to the Necrocube piece, serial mutations,
And
right?
these
I
are
mean,
yeah, I want people to walk around and try to, understand things in space. And that's definitely this serial mutations kind of comes from that as well. Is this kind of architectural scale of 3 dimensions, but then it shifts to totally flat, and it's about kind of the perspective that you have on something, and just by overlaying different colors on top of another, you can create the idea of space. But then, in this particular instance of this work, as you walk around, it's super flat, on just a wall floating in the room. So
yeah, yeah,
Yeah, that was the I think the first piece of work that we saw of yours at the gallery in
on Saint
Montreal.
Catherine.
yeah.
Yeah,
Yeah,
and it's really good. You watch it for 20 minutes, and like obviously, well, not obviously, but it never repeats. And basically, it's a set of it's basically the optical illusion that happens when you have a cube that's rotating, and it gets to a point where you can't tell whether it's inside outside what you're looking at. And I think you're playing around with the some parameters like making some faces transparent, colored differently, larger, smaller, that kind of thing. So it was at times like this right now it looks really flat, and other times it really looks like it's a 3D thing. Or sometimes you only looks like it's a 3D thing when you are going from one state to another, right? So it's like when you're at the midpoint, oh, that's actually a 3D thing that's rotating, and then it comes straight again. It's like, oh, that's just a
yeah.
bunch of flat things. So it's kind of interesting.
It really messes with you.
Yeah.
It's a little bit holographic in a way.
Yeah, I
Yeah.
mean, I love pieces that, whenever I work, actually, I try to make things that have a surprise for me. And I
Mm.
think it comes from coming from a video background where when I was done editing a video, I never wanted to see it again. So when I finally was able
Mm.
to do things with software, it's just like, you know, it's that old trope of like giving a set of instructions and then you kind of leave a wide enough berth for
Variability.
it to kind of do something that keeps you engaged, and then that's, you kind of get this feeling like, okay, this is it now, you know, and it keeps you interested and keeps you surprised.
Nice.
Yeah.
So did you spend a lot of time kind of finessing what the parameter transitions would be, or what the ranges of parameters were that you're changing and stuff like that to get it kind of?
Yeah, a lot. And the timing and,
time.
you know, just even the easing functions, you know, you have to I spent a lot of time staring at this and making ever so slight changes. How it goes from sort of monochromatic to like here it's kind of a lot of different colors, but then at other times it's almost all the same color. Like I spend really a lot of time with that.
Yeah. That's cool.
Yeah.
Beautiful. Yeah. So yeah, your stuff is kind of like an illustration of the behavior of like materials in the first thing, or in this case, just geometry behavior, an illustration of behavior of just it's very simple geometry.
Is it running anywhere right now?
Right now, no. This one is not running, but I've done a lot of iterations of this. It was just over during the COVID times, I guess like last year, was on a big wall-sized projection or video wall in Seoul. That was really exciting to see it at that scale. It's fun.
Wow. And it never repeats.
I mean, no, I guess.
I mean, as far as you know.
But I don't think it would ever repeat. I mean, there's so many layers going on that I don't think you'd ever see it again. It returns to, you know, there is a quality that it keeps returning to, but it's never the same color or layout or exact size or anything.
Let's segue here to delta T.
Another very science.
Yeah, big time. Lasers, points cloud. That's at AV Performance with Piers Wanaka.
Exactly. Yeah. No, that was the sort of second piece that we did. And this one we tried to use, I mean, it came about because we were reading this Carlo Rovelli's books. I don't know if any of you guys are familiar with him. He's sort of he kind of talks about new theories, and I'm going to get lost in I'm not an astrophysicist, but he kind of talks about how gravity and time are kind of, you know, he's trying to do what do you call it, like tie together the sort of universal theory, I suppose. So I found this data set. Actually, Marcus helped me a lot on this, of all the stars that you can see from Earth, which I think even turned into a tutorial at one point.
Yeah, I remember that.
Because I was trying to wrangle these things and make them work. This is at least for the beginning. And we kind of took a lot of this Carlo Rovelli's ideas and tried to sort of create kind of different feelings around them, sort of the curvature of space and how things are related. And we really wanted to use a laser for a long time in performance. So it was the laser is actually overhead in this piece. So we have these cones of light that appear within the crowd. And again, it's kind of, it's more about bringing people into a particular space rather than projecting a kind of an image that's necessarily relatable, let's say. It was again one where we were trying to encourage people to walk around and see it from different angles, and so the laser really kind of helped with that. And it's been a lot of fun to play.
What's the projection surface? Is that a dome or?
No, this is just on a flat screen, but then we perform in the center of the room, and the laser is overhead with a like 180-degree special lens, so we can actually go almost 180 degrees out to the walls and create a whole kind of ring around the boat, so I can open it up and things like that.
Yeah, it's cool. At times, the laser looks quite separate from the image, but at other times the laser looks like it's part of the image and it's not distinguishable. So it's kind of cool. I mean,
it was really hard to photograph this or document this work.
Yeah,
it was a tough one.
Yeah. if you listen to the audio of this, which you would if you went to your site, I found some really nice connections between the sound elements and the visual elements. Maybe you can talk about that, working with Pierce, and how you tied together some, like, for instance, there's kind of a wobbly thing at the beginning that Marcus showed, and that was very tied to some sound elements. But did you kind of like go section by section and start tying some visual things to the sound, or was that kind of all manually controlled by you?
We kind of worked on things really collaboratively as well. So I think Pierce had a couple of particular ideas about how he wanted to compose the sound, and so then I would be like, okay, we can tie these things together. And I also went to him with visuals that kind of had their own look, like especially this one at the end, and the other one with the cubes. I came to him and said, what can we do? And there was one tiny clip that we just saw that has some triangles and it looks like a Kandinsky kind of that's moving around, or like a constructivist work. And that's actually all using in the physics, the flex stuff in TouchDesigner. So as things bang into each other, I'm sending him some OSC. Yeah, these parts here. And so I'm actually sending him all the information there, and it's kind of, I don't know what he did in Max and Ableton to kind of tweak it triggers some of his software synthesizers and things like that.
Yeah.
And then, so it's a big kind of data feedback loop, mostly OSC, that we just kind of construct on our own.
Oh, that's great. Yeah, it's good to see some like visual elements feeding data into the sound system and doing whatever, but that's not very common. But
we try to do that a lot, and I think it's more fun for him as a composer. He also works visually, but when we collaborate, it's sort of pretty standard this way, and I think that's why he's so open to working that way. And it's a lot of fun to actually crank the color or scale of something, and you're going to have a really direct kind of impact that way, rather than always, because it's been a long time of just following what's on the screen, which is also really effective, but it's nice to have this kind of tension when we're working.
Yeah, awesome. That's great.
Not to interrupt, but to interrupt, and on the topic of time, we're going to run out of it. So and we had so many things we wanted to talk about. We wanted to talk about the Arctic Perspective Initiative, which doesn't have anything to do with TouchDesigner, and we wanted to talk about Take Nothing for Granted, Star Valley Sirius, and Spillover, which we definitely need to talk about. So I think should we pick a couple? Should we?
We can jump right to Spillover if we want to. The time.
I mean, we should have another. We should probably have another in session maybe, so we can talk about the Arctic Perspective Initiative.
And Star Valley is so incredible. Okay, Spillover.
Yeah, well, just maybe for 1 minute on.
Because we're all going over time usually, I think we should keep going and look at Spillover. Yeah.
Okay,
Sure.
but honestly, check out more of Matthew's work on his website. That's all I will say. So Spillover, you're performing it at MUTEC in the next couple of weeks.
Exactly, and Spillover was actually commissioned by a new, I think it was the second edition, or maybe the first edition was like a preview edition of this biennial that's also happening in northern Portugal again, in Braga. It's called Index, and the theme this year was surfaces. And I had been in touch with this curator because it was the same curator who set me up with the installation, or with the residency at the Nanophotonics Lab, and we were just talking about some different ideas, and he had mentioned to me about this lithium mine that's in the north of Portugal.
That's insane. That whole concept, that basically sort of that rare earth mining and the removal of a mountain would allow two villages that are separated by the mountain to in fact now see each other.
Yeah,
which is kind of a staggering idea.
it is really. I mean, so yeah, he took us to meet the activists, and Pierce and I thought what we could do is, and we've been having this idea for a while of using the landscape to actually generate parts of the composition. And so this seemed like the perfect opportunity to do that. And we hired a fellow with a GIS guy with a drone, and we told him where to make the maps, where they were going to propose to build this mine. And also then the activists now have all this 3D data that they can use in their own fights to,
Oh, nice.
Convince people that the land is more valuable as an agricultural and ranching area, that it's UNESCO recognized, rather than be they'll make a lot of money, but then in 20, 30 years or whatever, you're left with just a hole in the ground. Never mind the amount of water and everything else that it takes.
Exactly.
And so we found it really interesting, it's an interesting paradox, and it was the perfect opportunity to kind of really dive into the point cloud work, which this is really, beside the small kind of project or part of the Delta T, where there was the universe, just that small chunk of data, the visible universe. But this is the first time to actually use point clouds in a really serious way. So it was a huge learning process that I'm happy to talk about.
And that's what we're going to explore more of today, right?
Yeah. So when did you start working on the project? I.e., when did you come into the point cloud thing? Was it about a year and a half ago? When we started to introduce it with TOPS?
I think we did the flights were in December, and we showed the work in May.
Okay.
So it's quick, yeah. But I was looking at, I guess I kind of knew I was going to do that. So maybe, yeah, it was 9 months of trying to understand how to really do something interesting with the point clouds, or at least I always try to have I love new technology and I love messing around with things, but I always feel like there should be a good reason why to use a particular technology.
Yeah, we've got to connect for something.
Mm-hmm.
And again, maybe we should dive in with Jarrett, because Jarrett, you may have to leave early today, and he will not be forsaking us. But so
cool. Yeah. So
Disconnecting
I had a
to you,
look
Jared.
over your file, and Marcus told me kind of some of the things you were looking at,
So Jared,
trying to improve.
Jarrett, one sec.
You would have to allow me to connect to you.
Thought we already did that. Sorry. There we go.
It's pretty.
Good. Yeah. Okay. So, Marcus told me a little bit about what you were looking to improve. I think we should start with your file, which is this file here. Yeah, okay. So you're using Scene Changer, so that's cool. And
thank you for the Scene Changer, by the way.
Yeah, I'm glad you're using it. And you're using it, I mean, as far as I can tell, correctly. And so that's great. As well, I can see that you're kind of keeping your MIDI and OSC external control stuff in one place, which is kind of, I think, a good idea. I'll show you some ways to structure things a little differently. And then your UI is kind of over here on its own, which is actually a good thing too. Looks like you were using a different system. Maybe that's the 440 system here.
Exactly. Yeah.
Yeah. and then you move to widgets. So we could go over, and then we've got your sort of your knobs, or you're just using a knob. You're not using a button, and we're talking about the MIDI, the MIDI fighter, right?
Exactly.
And the MIDI fighter's got for every knob, you can also push the knob. So every knob's an actual button too, right?
Exactly.
Are you using the buttons?
I am. Yeah, there's everywhere that you see like a letter inside the knob, that's just to remind me that it does act as a button for a particular function.
Oh, like here?
Yeah, exactly.
Yeah, here. Okay, cool. Yeah, I didn't fully comprehend that. So I have a recommendation. Well, I mean, ultimately, yeah. So how are you actually turning it into a button? What are you actually doing right now?
I'm not actually the UI for me is just so that I can keep track of where I'm at in the performance, and that's why there's the color adjustments, because you can change all the colors of the LEDs on the thing. So it's like I think it's kind of like 2 scenes for every bank of knobs, and they sort of change colors as you go through, and then I sort of know where I'm at in the performance, or what knob does what. It's almost more feedback than it like visual feedback than it is that I click on anything on the screen. I tend to not really use the mouse at all.
Right.
Except for maybe at the very end. There's one button.
Yeah, like these buttons here, the scene change happens. How are you changing your scene?
Actually, the scenes are getting changed. That switch at the top there will flip it over so that there's a MIDI note in an Ableton set of Pierce's, and those kind of the scenes get triggered from him. And those are just like override buttons. So when I'm trying to build this thing, like I can control the scenes. So it's sort of a double control, but Pierce was setting it off, so I had to have like a toggle to turn it on or off.
Cool.
So using the override shop to manage that, like on-off coming from Pierce, or on-off coming from your gear.
Exactly, but if I didn't switch off his MIDI, then it would get like as we were kind of prototyping all this stuff, it would get set off when I was trying to fix a particular part or whatever. So then during the performance, that's always on, and I don't change it.
You don't touch it. Yeah,
exactly. That's why it's just a super dead simple kind of thing.
Do you have another controller, or is your main controller just a MIDI fighter? Or?
Just a MIDI fighter.
Yeah. Okay. Cool. So cool. Yeah. And so what else is nice is that you're changing. It's context sensitive. So you're changing the MIDI fighter has 4 different pages on it. Right?
Exactly.
So each page, so that you can see the page change because this one's red. So this is on the red page, I guess, or whatever.
Yeah, exactly. And it changes the LEDs on the fighter itself as well. So I'm kind of like, oh, okay, red, green. I'm kind of know where I am.
And yeah, exactly. So you're sharing. It looks like you're sharing page 1 across a couple scenes, and then you share page 2 across a couple scenes, and so on.
Exactly. Yep.
Yeah, cool. Okay, which is really nice. I mean, that's awesome. MIDI Fighter is a great device. So people out there, we're supporting it more and more because it's such a useful, basic thing, and it's affordable. Okay, so I'm gonna hit escape, and there's a lot of this going on, which we can, I kind of, I'm going to show you a different way of maybe looking at the MIDI. Looking at a user interface to kind of mimic the MIDI fighter, and then some strategies for mapping that back to OSC and MIDI. And so one of the things that I don't have a MIDI fighter on me, and so I was like, oh no, I didn't bring a MIDI fighter with me. I'm in Canada right now, so instead I made a MIDI fighter simulator with Touch OSC, and it's the new Touch OSC. So a lot of you might probably know about Touch OSC. It's been around for a long time, over a decade, and and it's come out with a new version, which is really nice. It's scriptable. It's got Lua scripting in it. It's much more advanced and a really kind of clean system for building stuff. So I would recommend this for you anyway, Matt, because it's only like $20. And it allows you to do all kinds of cool things with both. Like, if we just look at one slider here, this guy, you get all kinds of controls for setting up what kind of MIDI it's sending in, which type of OSC message, and the name, and blah, blah. So what node it's sending, what channel it's sending on. And so it can be even a conduit for the MIDI fighter itself through your iPad or iPhone or whatever, and then into Touch. And the other thing that's nice about it is if you're on the road or on an airplane, you can actually use this locally. So you don't have to have the device with you, and you can. I didn't have the device to make it exactly the same, but we can do that. So we can make this sort of template for people to mess around with a MIDI fighter before actually having one. And so it's really just a knob and a button. So, these are two separate widgets or whatever you want to call them. And it just happens to fit nicely in there, which I think Marcus said you were interested in kind of how do I unify a button and a fader together.
That was a question from Matthew, exactly.
Yeah, definitely. That was something that was I just didn't have time to go that hardcore into replicating my MIDI fighter.
Cool. Okay. Well, so that's what we're gonna try to get through all that, and then I also have some quick recommendations if we have time. We can go into your scenes, which are sorry, wrong guy. Into your scenes here, and we can just look at if we can clean up these a little bit because of all the work that we've done on the backside with the user interface, and where do we get our values from? Like, you're getting your values in via some expressions and so on. So we can take a look and see that. And then also cooking issues, which maybe I'll mention in the end. So, okay. To start, what I'd like to do is show you kind of, I already had this built, which is essentially just a MIDI fighter UI. So my quick answer to you about unifying a button and a knob is don't put them on top of each other, because we don't have good support for like a click map. Because you would really need, if you wanted, like if you see here, I can actually click through, like this actual gadget is like a vector. It's kind of really nice the way that they have this set up, and you can put a circle in the middle, and then you can turn them both into buttons in a slider. We don't really have that because the container will allow you to click through it, but if you wanted to have a circle shape, you need to have some kind of click map to click through, which just don't support that out of the box. So if we look at this is really quite simple. This is my version of what they've made with widgets, which isn't that different from yours. I just simply added in a button for every knob, right?
Yeah.
And if we look inside here, if we look at just one item, we got a knob and we've got a button, right? And that's all pretty simple. So if we look back at your file, though, let's just take a look at sort of maybe a little bit less structure. Well, first of all, you've got one whole user interface for every MIDI fighter. In the case of the MIDI fighter, it's one MIDI fighter and there's only 16 knobs, and then you push a button and then you switch, right?
Yeah, exactly.
So you've got extra gear than maybe you don't need. It's a lot more tricky to set up. But I'm gonna show you how to unify your user interface tool and separate that from your values, because right now I think things are a little bit conflated with regards to like your user interface and then the values that are getting sent out to your functional scenes, right? And you can run into all kinds of trouble. Like, for example, you might want to change the user interface. You might get what happens if you buy a different MIDI device that you like better, for example, right? So, and so right now, if you had to rip that out and you'd have all these direct connections, into essentially this guy here, right? So like this, we have your like names coming out of your user interface, and then they're going out to your scenes. So I'm suggesting don't do that. In fact, I would suggest to everybody is to never use these outputs. So that's, I know they're there, but I would suggest you don't use them. And then what you want to be doing, which you're kind of doing here already, is you want to bind the value on the user interface element should be bound to a real value, right? So your user interface, and so if you look back here, this component is a single 16 knobs, 16 buttons user interface. We can see that's just gridded out really simply with a container setup that's pretty basic. And all the values are bound up to the parent, to the knob 1, knob 2, and so on. So if we look on the user interface element, the knobs on the inside are bound to these parameters. These are then subsequently bound to other things, but this value here is coming from this parameter, and this value here is coming from this parameter, right? So if I turn this on and off, this is the parameter going down. So the way you're always kind of creating these bind structures, and so you kind of want to be going up, and you want to keep things contained. The reason for that is this as a component, it doesn't do much. It's just a knob, and it's just a knob and sliders, and the values are here, or they're pushed up to the top, and that's all it does. Like, it doesn't have any MIDI control. It doesn't have any pages. There's no pages. There's no notion of different pages here. It's just a user interface that's bound to with user interface elements that are bound at the top level, and then that's it. And then what you can do with this is you can bind that to something else. And so in this case, we can bind it to pages of parameters, right?
Okay.
So, and now we're talking about the difference between a user interface and its, in this case, widgets. Yes, widgets have values. I wouldn't think about the widget value, the value parameter, as a place that you store your value. It's a place where you bind your value to. You bind the value to that value parameter. What you should be doing as a guy building your system is thinking, where do I want my values? You probably want access to your values throughout your system. Like you might want you want a central place for your values, and then you want to go into scene 1 and utilize those values there. Maybe you want to use them again in scene 3, so on. That seems to be the way that you're working. So the way I had set this up, I would probably not even have these inside of here. I might have them up 1 level, but at any rate, there's 4 pages of parameters, right? Yeah. And so there's 16 buttons and 16 knobs. They're called knob 1 through 16 and button. That was because of something I built a long time ago. You might even call them value 1 through 16, right?
Right.
And or toggle 1 through 16. It can be abstracted like that, right? But this is your value store. So the point there as well is if you wanted to make a preset for your system, that's where you would make your preset, right? And then as well, if you're going to override values from a controller from the outside, you're going to push them onto there, right? So the values, these 4 pages of values are the central repository for all of your values. So,
and those components are it's really just to hold the values. There's nothing inside those.
Yeah, they're just empty. Yeah,
really
exactly.
Just that. Okay.
Yeah, I don't think that even matters. Yeah, so it's just a base component with 32 values, 16 floats and 16 toggles. Then at the top level, the MIDI fighter sort of architecture, there's the internal user interface, which is just the 16 set, and there's the page system. Then I have a page system just like the MIDI fighter. So page 1, page 2, page 3, page 4. When this parameter changes, it just changes the expression on it just changes all of these expressions, and it changes the binding from page 1 to page 2. So if we look at me changing that again, page 1, I go page 2, notice page 2 bound. So when you change an expression, a bind expression, the bind target, which is like the lower level bind, will change to the source. So when you say look at that, it will take the value from that. It won't push its values up. In fact, it'll inherit the values. So that's why you can take a user interface and you can point it at different things by changing the bind expression, right? And yeah, so that's really quite simple what it's doing. And the code for that is just like, it's in an extension, and it's like one line of code. Look, it's right here. For par in all the custom parameters, change the bind expression to be the page name, and it's connected.
Wow. Okay.
Yeah, so that's really quite simple. And now we've sort of got, and you can see these are green, which is a little bit misleading. But again, to ignore the greenness, those are just values, and but they're being bound from above. And so we're going to go to another level of binding, and now we're going to talk about binding your controller, your externals to this system. So to recap, the MIDI Fighter user interface is bound to the page, right? It's looking at different pages of values. Now those values are sitting there, and you can now bind. You can push a bind on them from a chop export. So if we go up here.
Hey, Jared, good question. Because they're exporting, if you would move the button, wouldn't it destroy the export that's bound to?
Oh, that's a good question. So why don't we do that? So I'm going to copy and paste this. It might have an op shortcut. Yeah, it's called MF1. I'm going to remove that global shortcut, and now it should be happy. Yeah. So I just created a new one, but this is a good test for your modularity. If you can just copy and paste something and have it be happy, right? So if you bought another MIDI Fighter 2, you're kind of ready to roll it already. And now let's go take a look at the parameters here. That's probably, yeah, I mean, ideally it would push back, but that's sort of Touch's fault, in my opinion. But at any rate, you'll see that these are just values, right? Sorry, this is all kind of pre-set up, so I probably don't have time to go through and just set all this up with you. But anyway, this is what it should be like by default. It's just a set of values. And so have you ever, yeah, you've used the bind shop. I've seen you use it, right?
Yeah, I have.
Okay, cool. So, so the thing that we've done is we've created this conduit through which external control can pass through to our user interface through our values, and we know where our values are. And so the easiest way to create a bind onto your values is to create a list of your parameters that you want to push stuff onto, right? So what are that? What's the list look like? It's object, it's component P1, P2, P3, and P4. And then if we look at the names of these, it's knob 1 through 16 and buttons 1 through 16. So how do we make that list? Let's just make the list. Let's just take a look and see what that path might look like. So I used a parameter chop to do it. And if we look at this long list, it's kind of cool because we're making these relationships. Like if you were to try to do this at Ableton Live, there'd be a lot of dragging and dropping, but we can actually automate this. And so this is the list you need. Don't worry about the values. It's just the names. It's just the strings, right? And it's because I extracted everything, all the components with a capital P from MIDI Fighter 1 using a parameter chop. And then I get the name format is the full path to the name. And then the creation order is legacy. It's actually I reorder it anyway. So we got all of our pages and all of our names. That's just getting all the custom parameters from those guys. Okay, fine. And then I reorder it using, I want all my knobs and I want all my buttons. Okay. And that's what we have here. So now I've got all my knobs first, knob 1, page 1, and then down to page 2, knob 1, and so on, right? And then after the knobs are done, you get all the buttons, okay? So this process is important because what you're doing right now, before you're even mapping controllers, is you have a list of all your values, and now you can create a mapping to push things into there, right? Push into all those slots, right? So now let's do, so we've got that list. We know what it looks like. We have 64 knobs and 64 buttons. Okay, cool. So now we can come and we can look at our OSC device. So I'm going to reset the channels. So they're going to come in randomly from the device, right? And so this is an OSC in chop. You could also do this with code, but I thought I would do it with no code. And instead, so if I come here and I just move this fader, which is the same as you moving the knob on your MIDI controller, we're gonna get a channel and it's gonna be radio 1. If I go click this button, it's gonna be button 16, right? And we're gonna get this randomly stacked based on the first in, the last in of all of the things coming in. That's gonna be out of order, right? You're gonna have a bunch of channels out of order, and it's gonna be growing slowly forever until you've touched every single controller.
Right.
So the way that you deal with those changing lists like that is to use a replace chop. And so this is a classic move, and everyone should know about this. It's actually in my last video online about widgets as well.
Yeah.
But you have to make your order. Now remember, and the constant chop is amazing now because you can just dynamically create new items, and then you can still use this nomenclature, which is a string and then a square bracket and then some numeric range, and it'll give you, radial 1 through 64.
Oh, that I didn't know. That's great.
Yeah, so that's easy now. So we've got a mapping of 128 controllers, and it says radial 1 through 64. And it's hard to show that, but let's just do it. And then down to button 1 to right? So over the last day went through MIDI or through TouchOSC, and when I don't have the MIDI fighter with me, I know it's a strange order. Like it's not like 1 through. It's the numbers jump around and stuff. I don't know what that is, but you'd have to meticulously go through and establish what that order is. I've done it before, and it's not linear. But I went through and I clicked on every gadget, went down to its name, and called it radio 1. Then I called this radial 2, and I called this radial 3. Blah blah blah. And I also did it for MIDI messages. I went channel 1. Controller 2, there's 1, 0, 1, 2, 3, and then I just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then all the way to 64. Okay, so all the work was done in here inside the hardware, and then that's the MIDI order, but this is the order that I want them in. So you take an unordered set of names with the values and you put them in the second input of replace. Now you've got an ordered set. This ordered set of 64 channels of knobs and sliders, or knobs and buttons, toggles or whatever they're called, matches. What happened there? matches this order. Okay,
Mm-hmm.
that's the trick. So we've just been dealing with English words, right? And
Mm-hmm.
we're just matching lists. Once you do that, then you can rename this incoming list to this incoming list, right? And then you can put that into a bind chop. And if in the bind chop you use the channel named is path parameter, then it's going to automatically push the name that you extracted from that network back out. So the value is going to go to the right location.
Mm-hmm. Wow.
And so if you repeat the process for MIDI, for example, which is it's a different ordered list, and so you're going to get a different random set of control values, But if you batch everything up, replace, and you do the exact same thing, now you've got a MIDI mapping and you've got an OSC mapping. And if you connect them both to the bind chop, it's kind of like a merge, right? Now you've got the last MIDI value or the last OSC value that comes in will go. So you could have, you could have you could have your MIDI controller and Touch OSC all connected together with Touch this way.
And the pickup function will still work with both merged or whatever. Like, is that what it's called? I can't remember now if it's pickup or not. Like where it doesn't jump kind of thing.
Yeah, channel pickup. Yeah, exactly. Yeah, exactly. And that'll also work. And so like a fun extra thing is you could actually even have an automation lane, right? So which you could turn on and off. Like you'd say, okay, I want this controller to go automated, right? So this is automation lane. And again, this was just done with a noise chop using the same language for the mapping, right? Which is I want MIDI fighter page 1, knob 1 through 16 to have different random values, stick that into bind, and then everything's automating.
And it's just going. Oh, that's great. I mean, then all of a sudden, you could have LFO banks and all sorts of stuff. That's great.
Yeah. As well, the good news is, like if we go into, like just by following this recipe, then if we look at the performance monitor, and you'll see that my user interface is cooking right now. See how the knobs are there? Knob cooking.
Mm-hmm.
Okay. But if we turn off the view and do it again, sorry, the UI is now not cooking because the UI is downstream, right? It's not it's not conflated. So there's not data flowing through your UI at your system. It's an appendage to your values. So if you're not drawing and that, like even now, like we're getting a user interface out of the MIDI fighter, but we don't have to be looking at the touch one. So that's a huge cost benefit for not drawing the UI and all that machinery behind it. So yeah. So you can see that here, right? Like if we look here at the automation lanes, these guys are automating. This is downstream. Therefore, if it's not, if you're not looking at it, and right now it's not even looking at that page of values, right? It's completely off. It's looking at page 4. So if we want to look at page 1, switch to page 1, and now this guy's cooking. But if we're not looking at the user interface on the inside, then those knobs won't cook anyway. So that's the whole point of following these sort of structures. Okay, so that's okay. But as well, I didn't show you why are these knobs changing over here, and so really quickly, you can. It's really simple. I'm probably going to fumble a bit because now I'm in a rush, but the source, this is a callback for the bind. When a value changes here, or when this cooks, I guess, because it could be any value, then, well, it's going to tell you the channel that changed. It's going to tell you the value, and it's going to tell you what changed it. So that's why I call it these names. What changed, the source the name of the source, this is a component, or this is a chop. It's actually not just a chop. It's whatever changed it to the source, but it's some kind of operator. It needs to be analyzed. It needs to be looked at. So it's an operator. So I check its name, see? If the name is not MIDI or OSC, then so let's just get rid of MIDI because it's going to be confusing to talk about both. If OSC changed the bind, we don't want to send the value back. But if I changed it on the UI, and let me get rid of this other guy too. If I changed it on the UI here, you notice this first knob's changing.
Yeah.
So the change, the source of the change is coming from MIDI fighter, which is this. So if it's not OSC, then don't send it back. So it's really that simple. You just say, if it's not if the source is not OSC, then figure out your routing back to the correct location. So if it's the first 64 channels, then send it back to /radial, the OSC message back to the source, and then otherwise send it as button 1 through 64. And notice I subtracted 64. And so, yeah, you always have to do a little jiggering to kind of figure out. And with MIDI, it's going to be even more sort of jiggery, but it's really quite simple. And that's the whole point of this callback, is to allow you to get your values back out to your devices.
Yeah, I think I was just using another MIDI out to then activate the MIDI fighter itself. This is a way smoother way of doing it, actually. So it's sort of like yet another MIDI thing rather than just a callback.
And yeah, there's the OSC out that's going to send back the message, which would be a MIDI out for a MIDI out DAT if you were doing it with MIDI. So you're probably going to have two MIDI, an OSC out and a MIDI out DAT. Okay, so we've done all that. We've got our controllers bound to our user interface. It's all nice. It's not, our user interface is only being used when it's being looked at and interacted with, and we're not conflating our values with our outputs from our user interface. Good. So what do we need to do next is we need to use those values somehow. So I was looking at your networks, and you've got many different ways that you're kind of trying to talk back to home base. So yeah. I'm going to give you a strategy here about, now that we know one of the most important steps we had to take was put our values somewhere useful, right? Or know where our values are, which they're not in the best place in my mind, for your use case, but we know where they are. They're right here, right? They're on these 4 pages of values. So what I did is in the, you're not using parent shortcuts and stuff very much, and I would suggest that you start using them more. If we go up here.
Jared, just a little time check here, about 40 minutes in.
Oh boy, okay. Let's just go really quickly in your file, because I ended up taking this, and putting it into your file just to see what would happen, right? So all we needed to do was copy what I just showed you in. Didn't change anything except one thing. I added internal op shortcuts for MIDI fighter page 1, page 2, page 3, and page 4. Those are the components with our values, right?
Right.
So if we go inside of one of your scenes and locate one of your fetches of parameters, like this guy, it's like, where is that really coming from? It's coming from the parameter up there. Okay, not sure.
Yeah.
And you have many different versions of this. Instead, it could look as simple as this. So here's some examples. You could get a parameter chop and just do iop dot page 1 and then grab knob 1. And the nice thing is, if we look back up here, oh boy, so many things to show you. If we look back up here, and we go into the pages area, not the labels, I followed your naming conventions here. See, you recognize these, right?
Yeah.
But it's really knob 1, but the label is color phase, and that changes when you change your pages. So see, the system uses the label name as the
Okay.
okay. So what's nice about that as well, the added benefit, is when you're inside of your scenes, when you click on the parameters dropdown, it shows you your label and the name.
Oh yeah.
So you can easily get at the things that you set up and be like, oh, okay, I know it's on page 1, and there I got phase or whatever, right?
Right.
And then, but it's going to come in as if when you click, it's going to come on as knob 4,
Right.
which is good, because at the lower level you want these sort of, black magic style connectors like index 1, index 2, index 3. You put the label on the tape, right? So, yeah, I think that's more or less.
And so the IOP, what is the IOP before the MF1?
Okay. Yeah. Okay. So sorry. So you can have as many of these as you want, and you can identify operators on the inside of your system that are hard coded. So like, are your pages? You need to like think real hard about where you want to put your values, right? Because they're important. You want to preset them. You want to control them. That's going to be a hard, steadfast thing into your system. So when you're identifying these things, you're kind of hardening your system a bit, which is good. You're defining it a bit. And this name is the IOP name. So when you type IOP, it'll be able to search and find that just by giving it this name here, MP.
Okay.
So here, I'll show you even another shorter way, which is even more lovely. When you use IOP, it has a notion of which parameters are on it, and that's called IPAR. So if you type this is really nice. I can just type IPAR, and you'll remember these, right? Because you're always going to remember MFP1 or whatever, my values. It could be IPAR, my system values, whatever. And then because you're using IPAR, you don't have to type par. And then you can just type the parameter you want, which is knob 1, for example. Okay. So you can type, now that we have this set up, anywhere in any scene. If you want knob number 64, you can just type IPAR and the page number and then the knob number, right? And then that way, when you're later, it's quite easy to know where these values are coming from, because I can just go here, select this, move my mouse over, and it shows me, oh, it's coming from /spillover MF1 modifier page 1. And then you're like, oh, that's where he puts the values, right? So it makes the system more readable.
Yeah, I've chased a lot of those values back and forth.
Yeah,
This makes it easier.
Me too. Yeah, and it also avoids the like needless pushing up of values all the way up. Like, I want to create a custom parameter, and I go and then I want to bind it to the parent and bind it to the parent. You can create a pretty flat system like this. Just put your values in one location. All your scenes use the same values, and then you can map your controllers to it. It's a little bit more free and loose. So.
Yeah, and you can just, if you want to know where IPAR.mfp1 is, just select that text, Jared, and roll. Yeah, so it's right there. You get the path of what it actually points to there. So anyway, it's a way of getting part of your expression evaluated.
Yeah, and as well, like this is the way, like, once we get our drag and drop system working better and get more of these tools sort of embedded in the touch, the drag and drop is going to be dropping these expressions in the long term. So these types of expressions in the long term. So you're better off now if you do it manually now. Like, we're going to support this method like more directly, and then there's other, like, we're also going to optimize for this workflow. Meaning, like, if you have a huge list of parameters like you do right now, it's 64 times 2, 128. If one changes, like, the whole network below cooks. A lot of people know this dark secret or dark reality, but we're optimizing for that. Meaning, so if you follow the recipe, eventually your system will get faster because you're working in the way that kind of pushing people to do it. So yeah, okay, cool.
Huge help.
Sorry for going on, but yeah, thank you.
No problem.
Thank you.
Back to you,
Thanks,
Marcus.
Jarrett.
Good stuff.
So I guess, Greg, you wanted to show some stuff next, so I'll connect to your computer.
Okay.
How long does Greg have?
Well, we now have
half-
approximately 40 minutes
45.
left between us,
Yeah.
because we need
So
some minutes at
2020.
the end. So we have
Yeah.
2020.
And I've got to go, guys.
15.
Great.
Bye,
Great meeting you,
Jared. Have a good
Thanks,
weekend.
Jared.
Yeah.
See ya,
Take care, everyone.
Jared.
Bye-bye.
See you.
Bye.
Hey. So I had a different take into your file. I avoided the MIDI stuff except for, well, for one thing, when I'm jumping around between parts of your my project, I usually have these layouts out here, which is basically shortcuts to different parts of your different components in your network. So anyhow, I noticed in Spillover you were using Windows multi-monitors, and I guess you might have got that from the I posted that a couple of years ago, I guess. Does that manage your two monitors with variable resolution monitors?
Exactly.
Yeah. Okay, that's good. Okay, so that was one bit of things.
That's not in the palette? I don't even remember. There's so many things floating around.
It will be in the palette in the next month
okay.
or so. It's buried in a post that I made a couple of years ago, but I'm generalizing it a bit more. But I find it useful if you don't basically if you don't care about the resolution of the screens, it basically makes out a map of open window for designer. Yeah. Anyways, it helps manage multiple monitors. Okay, anyways, I wanted to go into base 2 where all the action is, and you have this is pretty good. I don't know. This, all in one. There's a lot of information here, starting from your basic main model that you pulled in one point file which is indeed there it is kind of thing. And yeah, this is looks like it's a 3D geo, but it's the top, and the top, of course, if you go right click and say view as image, it's the 4-channel split or color, which is not interesting for point clouds. But view as points, yes, it displays as a 3D viewer, which is monochrome 3D viewer, so that's fine. I guess the main thing about your project is you're navigating around a whole bunch of I think about 4 or 5 or 6 point cloud files that are merged together. Is that right?
Yeah, well, each scene kind of has 1 or 2. Maybe there's one that has 3.
Yeah.
But yeah, it's generally 1. It kind of depends on what the goal of them were.
Yeah.
But, yeah.
So what I did for me, just for generally, I mean, this is basically your main camera out for your show, and often now that we have this component that's in the palette called camera viewport, which is basically a camera component, but with a kind of interactivity, which is similar to our geo and SOP viewers, which here, come see, come saw, it's basically the same kind of menu for navigation and stuff like that, and it is connected with a render top. So basically it is a real genuine render that you're looking at, not a kind of like fake one that you would see in a camera viewer or a geo viewer or a SOP viewer. This is the real deal. So that actually can be used for inspection or for some live show stuff, and it even has a auto rotate as well, so you can kind of rotate around your scenes and stuff like that to get a different form of inspection. So so I usually put that down just to look at things, because I wanted to look at how you're generating your how you're rendering your points. So I think you took a couple of stabs at rendering your Geo1, which is your main point cloud. And I guessed that you had tried out all these different ways of doing it with a point sprite, line, and constant and stuff like that.
I left all that in there, huh? Yeah, a lot of
Yeah. Oh, you didn't hide anything on us. Oh, you're going to hide it on us, eh? Okay. No, it's a good thing. It's a good thing because it really tells us, what people are doing to try and get stuff to look good. So you had this kind of interesting because all the instances for the points. What you had originally was you had a box. You had a box, a small box, which is a tiny box that what was its size?
Oh, yeah.
002 or something. Yeah. Whoop. Hang on.
Well, that was always a question because I put, by the time I put all those points into -1 and +1 kind of space, everything is super duper small. So I never quite zeroed in on the best way, like what the best.
It's okay.
Yeah. Okay.
Yeah, to have a scale, you can. Yeah, it's fine to scale it really 1,000th or 10,000th. That it should be okay. But so you had set it up to. Hang on. Now I'm getting. I'm getting a lot of lagginess here myself.
You turned the render flag on for the box.
Right. And you had it, and then you were using for the shader, use a constant shader. So go put it back to constant the way you had it before. Okay. So the issue, this is fine. So this is the way you had it. We're in a box at each instance, at each point. The problem is when you kind of get in close, everything kind of falls apart. Let me see, like the boxes become inappropriate size, really.
Right.
So there's a way to overcome that. Let's see. Yeah, getting close, you can see how it gets all fizzled out. So if you want, that's a look, and it's definitely a legitimate look to actually have things fizzle out as you get close. And you can control that a little bit if you switch over to the line material, which I have to go back in here and set the type to. Oh, I had it both as. I have to turn off box and leave it as the single point. Oh, that's why it looked the way it did. And assign the line material to it. Okay, back to our viewer. And now as you get close again, it fizzles out as well. Whoops. And that's because the line material is set to hang on, let's go to the material line. Sorry. The depth interpolation model is S-curve, which is the default way of doing it, which is the size of the points depends on how far you are from the camera. And it's kind of an S-curve where at a near distance, the size is 5, and at far distance, its size is 2. And for most art purposes, this is kind of what you want to fine tune. But for things where you want to actually make, for point clouds, you want to make the image look as full as possible, the better way is to set it to inverse distance, 1/r, which is, again, assign this over to the render line. Yeah, so what it does is it makes the, if the object is twice as close, it makes the dot twice as large, which makes the points fill the space more regularly the closer you get, kind of thing. So I'm pretty close into it right now, and my circles are bigger. And farther back, they're half as big and so on. So part of your model here that I'm looking at here, I think you have it split out in different parts. Some parts are the old way, set the old way, and some parts are the new way with the line material. But But anyways, it gives kind of a decent rendering of your point clouds at any distance away from it. So that again is another look, and you can adjust the size of that, of course. Yeah, with near and far, so kind of thing. So that you can adjust the size, but that's your main control. So, okay, fair enough.
Also saw you were using PBR materials at some in some stages. So
Some of it, yeah.
is
Okay.
is it
There's
is
a
it
couple of them.
mostly look based? I guess like how you can
It
dial
would
in your
mostly, yeah,
look
it's
best.
mostly about a look and the way that it would react with the environment light. I think it's just two, if I can remember correctly, I think there's just two of the scenes that use that. But when I was building this thing, I was just kind of, trying everything.
Yeah, well, that's good. No, and that's really that's what TouchDesigner is for, is experimenting and getting better or different or happy accidents or sometimes complete failures. But
well, you can do all that sort of stuff really quickly, which is invaluable. Like you can't really know until you see it, I think.
Yeah. So okay, so let's just move on from that. That's just a suggestion for if you are using the line material, to use that feature called inverse distance for point clouds. So you had a question about how do you find
well, one quick question about the line material, and with the way that it's working, kind of see it in the view that you have now. So as this camera is kind of spinning around, and see how some of the circles are drawing and overlapping one another in kind of a weird way. That I was having issues in that sense. Like that's kind of why certain looks or certain scenes didn't seem to work well, because it was almost like kind of sparkling, the way that
they're kind of popping on and off.
Yeah, see how they pop on and off?
Yeah, that may be related to the
where the points are. Is it like a Z fighting thing?
Yeah, and it might be related to the camera. Forget where your camera is that you're using. It might be Cam 2, but it might be related to the near and far settings, 0.001. Maybe this is a little bit too small.
Okay.
Let's say whatever it might be that, and far might be, your scene is between plus and minus 10, so 100 might be, so that might make it better. I'm not sure, but it's related. It might be related to precision. They're less sparkling. I don't know.
Okay, well, that's good to know. That's something that I can try to fix.
Yeah, maybe. Yeah. But I also noticed that the way it's you see their oval here and their circles here. I think it was related to some.
I must have maybe I have a really wide lens.
Yeah, maybe that's the case. Maybe it's the way the camera blending is blending two cameras together. I know there's a cam blend here is set to 0.9, which is almost 1, but not quite 1. So I don't know if I can just override this and say make it 1. No, that wasn't the issue. Anyways, so that might be a bug. So I'm going to check to see if that's a real bug after the broadcast. Now the question was, how do I? So if you want your camera to actually be hovering above the trees by some distance, or hovering above the highest parts of your landscape, wherever your camera is in X, Y, Z. So X is horizontal, Z is depth, and Y is up. So up. So you want your Y. You want to basically find out where, given an X and Z position, you want to find out what is the highest point of stuff that's in my point cloud, so that I can actually put my camera above it.
Exactly.
I say kind of writing landscape. So I took your path. So let me see. This is a component I made, which selects your point cloud that you're using, then selects your path that you were grabbing, and I just made a fake indexing with a lookup to get a XYZ value of the of that path. It was just a circle at the time. So, anyways, it's just a test position of the camera. I'm only going to use the X and Z value. There is a component in the palette called point field under point clouds, and it's used to isolate points of point cloud. So here, so there's different ways of isolating points via a bounding box. Hang on, relative. Yeah. So basically, you're trying to find out. You're trying to output a weight channel based on an XYZ and some criteria. So the output, the input is just this XYZ, and the output has the weight added to it, and the weight will be between 0 and 1, and you can define a box or a plane or a point. Relative to point really means proximity to ellipsoid, not just a point, and relative to plane, you know, on either side of a plane. So yeah, here it is, plane relative to point, gives you circular thing, which is in this case I have it set to be a very oblong ellipse. I'll show you in a second, or the boxes the way we had it set up. So basically it's a tall box. We scaled the box by 9, scaled it down in X and Z by 0.35. So basically it's capturing everything on the inside. You can specify a fade out range, which is how it doesn't have to fade out immediately. It's basically it softens the edges of the weights. But in your case, all we care about is things are strictly inside or outside a box. So we set that to 0. So this is the box. So what do I want? So in this case, the viewer of point field will set the size of the box based on the weight. So here's the instance size, the f.01, so we can make them bigger or smaller. And we have a minimum, we also have a minimum size, minimum weight, so that we can actually see stuff that's not being captured, but that's just for viewer purposes. Okay. So that's kind of just a convenience for the viewer. But what we're interested in is, in this case, I want to take all the points that are inside the box and leave them where they are, and all the points that are outside it, slam them down to y equals 0. So I can kind of isolate it so that I only have this set. So I do that by doing a reorder and a multiply. This is basically multiplying the weight, the y value by the weight, and then sending that into an analyze top, and getting the one single value is the maximum y value. So basically analyzing it. So I want the maximum green channel, which is where y is, and so I'm only interested in the green channel. So this is 2.7 whatever. So I pull that out and get the green channel only. So that is the position of the highest point. And then I'm just looking at a trail just to look at the results over time, and I'm filtering the y value so to make it a bit smoother. Sure. And so on. So this is just for viewing illustration, but this is my resulting value that I want out. And if I want to see it in a bit more detail, this is like the this is more the flattened geometry. So everything is 0. Everything is 0, y 0, except for my data that is from the point cloud that's within the box. So that was the technique I came up with for that thing.
Then how do you get because right now it's just cycling through the circle, but or are you getting is that the actual camera location? No,
no, I wasn't. I didn't get that far enough that I hooked it up to your actual camera location. So I would replace this part with a fetch of your camera location, but I couldn't find it while I was last night at 3 a.m.
Oh yeah, no problem. But
Oh,
when the camera is following, correct me if I'm wrong, if it's following a what do you want to call it, camera path,
yeah.
is that data fetchable though, or is it only, see, I think it's just like a number of like a 0 to 1 around the path. You don't get the X and Y of the camera.
You can get it if you get, I think if you're, I understand what you're asking. With an object shop, you can get the value of the, you put in a target option, reference option, you get XYZ and any reference frame and stuff like that. So you put it in different forms, and you can get the actual camera position with all of its hierarchy and transforms accounted for. Okay,
that's the piece of the puzzle that I was not understanding, actually. Okay, no, this is great. Like now I see how this will all
and
tie together.
And Marcus came up with a different way of doing it, so he'll show that when he. I got 3 minutes left. I do actually like a couple of things. You trying out expressions here and basically run this as a script and looking at the results. Is that how you're doing it? Text board.
Yeah, exactly.
The value here. So, whoops. Okay. So, anyways.
Trying different things to use that in other areas for like presets and how to start off these kind of scenes. I mean, that's sort of the way I was kind of.
Yeah. Well, sometimes.
Thanks.
That's good, because sometimes I would just put in an expression, evaluate that expression, and try and evaluate it there. And it doesn't, it's an error now. But anyways, sometimes I do it so I can see the value right here, and I can kind of tweak around with it without having the text board open. But both work.
Okay. Yeah.
But that's cool.
That makes more sense.
I like how you're using the comments for backgrounds. For identifying sets of nodes. There's a trade-off between using comments, which are more concise, versus annotates. If you right-click on the background, you get the comment menu, and you can't really right-click and add an operator there. So you actually. And so that's fine, but it's more draggable, stuff like that. But the point is, with the annotates, you can alt. Yeah, if it's behind, for nodes in it, it drags with it, and you can right-click and get the network menu. You can drag the top of it to move it around, but but below the menu bar, you're actually dragging the menu or getting the network menu.
And
the network.
The shortcut is Alt right.
Yeah, so you have your three choices here, which is what you've been doing is Shift A for Shift C for comment.
Okay.
So I use that a lot for just little notes around, and network box, put box around it, and that's shares the same property as comment, and then annotate, which is what we just looked at. So, but they're all the same code underneath it. So that's whatever suits your fancy. And almost done. I think I have almost 0 seconds left, right? Yeah. Okay. Okay. I think that's it for now. Then hang on. Just give me 1 second here.
Making up time.
I'm always. Yeah. Like Jared says, your scripts are good. Hang on. Here. Yeah, here it is. So your scripts are pretty verbose here because you have long strings, and you can use what Jared showed you, the I-opt. There's a couple of other ways of doing it. You can use something called global shortcuts. You opt dot, or arguably better, which is iopt.ui.par, and this would be pointing to, as Jared said, to the spillover set of internal shortcuts, which I put in a similar thing. Okay, anyhow, that's it. Marcus?
Perfect. Awesome. Thank you.
Yeah. Anyway.
All right. Well, thanks, Greg. Let me just disconnect from you. And
wow. I like how Jared is still there.
Like, he's really concentrating.
Yeah.
It's there.
Very serious guy.
That's
Right,
funny.
let's switch back to the screen here. Good, yeah, that's good. Okay. So I've got I kind of took stuff out of your file because just running this here plus your file was not possible for me. It takes up too much memory, so I kind of abstracted the problems a little bit. This is the initial one that we that Greg just talked about. One thing that is often useful if you have point clouds loading and a feedback loop behind, what you often get, and you get stuck with that little loading icon in the right corner.
Oh, right.
And what you can do is you can, especially when you're using composites that are ads or something like this, where the order is not really important, then you can just flip the order, and you don't get stuck with that little icon, and the resolution updates as well, because the point file might come in as a 256 by 256 initially. Anyway, so what did I do here? Oh, right, this was the camera. So yeah, different approach. I thought about it in a way that I want to look ahead and I want to know what's coming and get about it. Oops. The way that I did that then is, no, not top bottom, is to take the camera and write a little shader. It basically came up with a shader. So I have a basic camera that follows your path and that has the look at that you have in your scene. And let's just look at this in the geometry here. And you're with a little bit earlier on, you're extracting parts of it very nicely with the point weight component also from the palette. Anyway, so you're following the path with this camera, and then I put a null in there where I apply an offset, which I have to calculate, and another camera, which is the final camera, basically, where you can add your own offset because you're controlling the camera offset as well, right? Like you have a Y slider where you can say, okay, for the camera to go higher or not. So this is actually the final camera that's rendering. This null is the offset that I'm applying. And this camera here that sits at 0 and just follows the path and has the look at as well, is kind of my, where I get my reference camera, which
sort of baseline value or whatever.
Yeah, exactly. A baseline value is a good way to say that, which I use in a little GLSL shader to calculate basically what the render top is doing. So I'm just looking what particles are or what points from the point cloud are actually in my view of that camera. And this can be done by fetching those 3 matrices, and you can have matrices in your shader in a GLSL top. So I have the cam projection matrice, the cam transform matrice, and the geo transform. Transform because I saw you applied some scaling to your point cloud, so I had to bring that in too. Or if you offset it as well, it all plays into it. Now, one important thing would be the projection is easy to grab. Like you can just do a cam dot projection, something like that. For the transform matrix, you actually have to grab it with the object chop and then invert it with the transform chop, because we need, for the calculation to calculate the points, we need the inverse of the camera's transform. And this I apply to another null because that's the easiest way for me to, again, like I apply this matrix to the transform matrix of a null, because then that's the easiest for me to grab it again with an expression, because I can just say up null 3.world transform, and that's it.
Okay.
That's the transform matrix basically there. And all that the render, well, sorry, no, it's not all what the render is doing. In a very simplified way, what the render is doing is it's taking the point position, which comes from your point cloud, and it's multiplying the geo transform matrix that I'm getting from the geometry component with the point cloud. Now, the alpha value of the point cloud is the active layer. And that's something that I have to replace with a 1. Then to calculate the screen position, I have to take the camera or the camera, that's camera position basically, or camera space. I have to take the camera transform matrix, multiply this with my previous created point position there. And then I can multiply the projection matrix with these calculated points as well, which gives me this clip volume. It's basically a new volume of positions with a W coordinate, which describes my left, right, top, bottom cutoff points of the volume, like what's not visible actually in the world, and the positive of the positive value of the blue, or of the blue third part of the vector, is basically my depth in this volume, and this creates a unified space, which I have to divide by the W coordinate again, or to get actually the really normalized space that I multiplied by 16 by 9. But what you get is the 2D representation of what you see in the render.
Amazing.
Of just those points. And this is then, you can use this as it's a nice visual artifact then as well, because it's basically here rendering out the 3D version of what your camera is seeing. And this is a mask, and then I'm following exactly what Greg is doing. Analyze the thing and get the average position out of that, filter it, and feed this onto the null, where I'm putting it above what's coming. Not what's under me, but what's coming, basically.
Yeah, what's in the frustrum or whatever that's called from the camera, yeah.
But what's coming how far away from the camera to the infinity?
No, that depends on your clipping, on your
Clipping
camera's clipping plane. Yeah, because
Cool.
if you just change this top here where you're reordering this, if we take input 1 alpha here, yeah, now you can see this a little bit. Oh wait. Yeah, that should be. No, I think that's correct. Right. So this describes now the clipping plane here quite nicely. And let me just change that in the camera. There's so little space on the screen there. View. So here, now you see I get like the whole thing. And if I keep going down, let's do this 10. And now. I think I was way off how big that is. But that's why I have a trackball. I can just keep going. Tick, tick, there we go. Here's how far I'm looking. There I'm controlling how far I'm looking, or from the other end, how close to the camera basically. I can change that as well, so you can see how far away from the camera it starts. And as well, I chose actually an FOV angle, field of view angle of 90 degrees, because if you have a smaller angle, you end up missing quite a bit also of what's above you, of course, like things that are like a big mountain that might be coming, you might miss that because it actually doesn't fit into your field of view. Anyway.
Okay.
But
and something it's not related, like if I change, I don't even know what to call it now, but like the way I'm extracting the points in this strip, like if I change the width of that, it doesn't change the width of what the offset changes, right? Like it, okay.
Because that's defined by the camera. The camera is the one that decides how far you see, how much you see. Yeah. So you could clamp it even what the camera sees could be shorter than what the strip is, or the other way. Well, no, not the other way around, because you're feeding in the strip. So yeah.
Right. No, that's great that they're kind of independent in that sense.
Okay, so that was that. Then
Far out.
disable that and bring up the hole drop. So the hole drop is fun because what you are doing is you're punching holes into the surface of the world. And what's happening is that what you were trying to prevent is punching holes in the same space.
Exactly. Yeah.
Trying.
Multiple holes were not more dynamic, I suppose.
Yeah. And what do I have here? Right. So I tried various approaches. First, I thought, okay, we do the Paqueta 12 approach and record all the holes as pixel values and traverse that in a feedback loop, like always take one down. This way I could record all the different hole positions and hole radius because you just need x, y, or xz and the radius basically.
Right.
And then I could overlay this with my current hole, and I could always figure out what the distance is for each row. And then I could see, oh, am I too close or am I far enough from a hole? But that doesn't tell me much. That's totally independent from the actual map. Like you kind of want to stay on the point cloud, I guess, and not in a 0 to 1 space around the point cloud. So I took this approach away. Then the next approach was, and that worked actually pretty well, was the idea that I just added another feedback loop into your feedback loop where you sync the hole.
Okay.
Where you actually create the hole. And
Right.
Maybe I should show that here. Trigger. That's that. Oops. Here as points. Reset. Do trigger. Yeah, that's better. So it created this hole here. And then I thought, okay, why don't I just remove those holes from the alpha channel, from my active channel, basically.
Okay.
So I record that in the alpha channel as well to say they're not there anymore. And then all right. Then I applied a noise to it. Then I apply a noise to all the remaining active points that are still there. So all the points that are still available. I multiply this with the noise. Then pick the highest noise value that I can find in that set. And this will return me some random RGB point cloud value where I can place the next hole. And
Okay.
If that makes sense, sorry, it
Yeah.
might be a little. This actually works fairly well. If I look at this here, if I trigger again, I get a hole, trigger again. So the thing is now that I'm not picking positions that are completely or where the center of the new hole is inside another hole, but I still get these overlaps here. So then I realized, okay, I have no way around this, or I don't know any other way but to write yet again a shader. But it's a tiny shader, and it's kind of a fun shader because it creates a nice little, it creates a nice visualization. It basically just calculates all the distances of every point to all the holes, to the closest hole. I'm assuming here that you're not creating a million holes, so
No.
that makes it fairly simple. And I'm recording these holes in a trail chop, using the trail chop with its active flag and the grow lengths to always, when you're triggering, it records a position. Okay, let's watch that trigger. Bing.
Mhm.
And now you see what happens here. My map now is this funnel because it's now describing for every, it's describing the distance basically.
Hmm.
And this gets more fun the more holes you punch. Because it's really creating this you're creating a lunar landscape almost. It's probably worthwhile rendering that better.
Hmm.
So,
Wow.
and now the same thing applies again. I take the remaining active points because I remove those points otherwise from the alpha channel. So I take the remaining, multiply by random noise, pick the highest noise value, and this is my new location for a hole. The way now, I have a threshold in here, and this threshold describes how close the new hole can be to the old hole, what the distance should be. And the way that
Okay.
this works is pretty simple. Like you can see, these are my actual, with a threshold of 0, you see the actual point cloud. And now if I increase, if I increase the threshold, I'm just taking away values that I can use as a new starting point. So the bigger I make the threshold, the less I
Less,
have
less.
available.
Mm.
The other thing that I added here, which is nice, if you analyze the whole thing on the green channel, on your highest distance, basically, of a point to the largest distance from a point to a hole, if I analyze that, I also get the maximum radius. So my
That's
maximum
available.
radius I could use is 3.5, but you could, so at least you have a maximum that you can clamp. If it has trouble finding holes, you can start clamping your radius so it can find smaller ones.
Find a smaller, and so for that threshold, is that just like, would that be like half the would it be the radius then, or not really? Am I totally not following the math? It's just
Maximum radius.
that's like kind of is it equal to the radius of the circle though?
Yeah, that's what I tried to figure out. Actually, I couldn't quite make a relationship.
Yeah,
Which might
it's
have to
just
do with the fall off. The
okay.
fall off range as well.
Yeah.
You have to kind of dial it in, have this as another parameter basically, or figure out the relationship there.
Okay.
I didn't spend the time going. I just realized, oh no, it's not double the radius.
Okay,
What
it's
I
not.
thought
That's
would
yeah.
be, but yeah, you see that it literally, it doesn't.
That's
When you
amazing.
choose it big enough, it doesn't overlap. Yeah, and I mean,
Very cool.
you can add further limitations to it if you want. And there was an overlap, so my threshold's not big enough. And yeah, so that's basically
Cool.
the idea. The other idea I had, which might be worth mentioning, oh shit, it's late. I also thought about, okay, you could use, theoretically, you can use the RGB key to find new places. And this would work the same way. You look at your incoming point cloud here, which has a bunch of holes in it. And then I had, with a point transform and the align page, I normalized the point cloud by proportionally into a 0, 1 space for the X and Z values. And now I have now I can use my red min and red max of my RGB key to find areas. So I could run now through with a noise or something like this. I could try finding places in here like this, and also with the red, like the size of your new hole, where I don't have any negative or no big green values, basically.
Right.
Because
Right. Okay.
if I hit a big green value, then I know, oh, I'm in an area where there's a hole.
There-
I kind of,
There's a hole. Yeah.
so this
Oh,
is
cool.
this approach you have to let run basically. After every time when you trigger a hole, this should start running and find a new spot.
Hmm.
This is a little bit, this is doing it by itself. It's a feedback loop as well. So there is actually a feedback job in play here to break the feedback loop. And something I have to ask Malcolm about actually, we do download this next frame. So why does the top two not act like a feedback job actually? Because it's a frame delayed anyway. I'm wondering, maybe that's something to look at. But anyway, yeah, so this is the little network. It was fun to find four different solutions. This one though seems to be the nicest one, and you get a little moonscape out of it.
Could you not pre-compute everything since it's a constant geometry?
Pre-compute.
Like where the
Locations
holes are
of where
gonna-
the holes would be. Just
you-
find 20 good ones for your show, and then and
Yeah,
pre-compute them.
that sounds like work, but yeah, I could do that.
Yeah. No. But
It also-
even using this algorithm, so it doesn't take too much time. Just do it once, Marcus, and just generate 20 of them, and then put them in a table and let them and pull from it when you need them.
This is pretty lightweight. Like it's 0.2 milliseconds basically.
Okay.
And you can always use cache tops to stop the cooking as well. That's another thing. If you have those things that only have to happen at a certain time, this doesn't
that's
have
a
to
good
cook
trick.
constantly. It only has to cook once when you're triggering.
Right.
So
Right.
Oh, that's a good trick, actually. Yeah, I hadn't thought of that.
yeah, the third thing, but I'll stop here because we have to go back. The last thing, I tried to figure out what was wrong with your shader, but I couldn't figure out that there's anything wrong. So I'll send you this. And
Okay.
I cleaned it up a little bit, like just erased what wasn't being used. And,
All the comments, yeah.
Yeah, and I wonder if that's maybe it's easier to recreate the issue, and we can go from there again.
Okay. Thank you. Take a look at it.
Yeah, we have still Jared there staring
Oh,
at the
Jared.
screen and wonder.
Yeah. Yeah. So I really like how you use TouchDesigner method. I can see how you do experiment and try things out, and you reach your good spots and bad spots. But I don't know. I think it just really fits in nicely from the way you do all your projects and kind of iterate towards like better and better looking things in the end.
Yeah,
And,
they get pretty. That's a spiffy version of it. I mean, things get really hairy in the interim, but at some point I have to clean it, or I'll never find where I have done something.
Mm-hmm.
And it's one of the things I notice the most as more and more I use TouchDesigner. It becomes much easier to know where to start, because I think with these, you kind of start doing something, and before you know it, you've got like whatever. I don't even know if there's a limit to the size of the network that it can be. Maybe somewhere.
It's infinite.
Oh yeah, okay.
It's a feature. Yeah, it's a feature.
It would be an interesting time travel experiment. How far can you go?
Just one more top.
Yeah.
So we have a few announcements before we go. Not that I'm saying we should go, but in the event that we will leave. MUTEC Montreal Festival is coming up, and Matthew, you'll be showing the latest version of this at A-Visions on Saturday night.
Saturday night, yeah.
Saturday
Number
night.
A-Visions 2, I believe.
A-Visions 2. And then Ali Fee will be at A-Visions 1 on Friday. And Marcus, your XR piece of with France Jobin is on during the
Yeah.
whole of Newtown
Yeah, running all week long.
all week long. And then there's a Touch Designer meetup hosted by the HQ, Interactive and Immersive HQ, that will be taking place at Automata's studio in sort of Mile End, Montreal. I think I'm going to make a post in community highlighting all those things, and that'll be evident, but it's also on the Mutex schedule. Anyway, really, really, really looking forward to seeing your piece on that big screen.
Yeah, me too.
It's going to be fun. I look forward to seeing you guys all there, and
Yeah.
whoever else is there, please say hello. Happy to hang out.
Okay. We'll snag you when it's over. I hope you enjoy performing it and stuff.
Oh yeah, definitely. Looking forward to it. It's always fun.
Yeah, it's too bad we couldn't get into the other projects that just so fascinating.
Yeah,
the whole tactical section. Yeah.
We can we can have a beer or a coffee or
sounds good.
Water.
Good. Beer, water. Well, thank you very, very much for joining us, Matthew.
Thank you guys. It's been I was really nervous, I have to say, to have all the head honchos go through things, but no, it's really great that you guys do this. I survived. I have to say,
flying colors.
No, but I really learned a lot by watching all of these in session, and just to see everybody else's approach and everything. It's really valuable. So thanks for doing these. I know it's not easy on top of everything else that you guys do.
This is fun.
Yeah. Oh yeah, we have product to release to work on.
Oh yeah, that
that thing. All right, and thanks guys for tuning in and on your Friday afternoons.
See you around.
Yep.
In Montreal, perhaps. Some people might be in Montreal, so that's looking forward to that. And thanks again, Matthew. This was awesome.
Thank you. Yeah. All right.
Number 20 is a wrap.
Right. Yeah.
Great weekend.
We'll have to see actually when the next one is, because everybody's traveling a bit. Maybe we'll do a remote one. So stay tuned for that.
Right.
It's going to blink by the next time, I'm sure.
I can't even look at him. Have a good weekend, everybody.
All right. Bye-bye.
Yeah.